Hi, welcome to Zona Mechanica. There is an MCQ on slope and deflection. Figure at the margin indicates the weightage of the question, that is 1 mark. Two identical cantilever beams are supported as shown with their free ends in contact through a rigid roller. After the load P is applied, the free ends will have equal deflections but not equal slopes but not equal deflections, equal slopes as well as equal deflections, neither equal slopes nor equal deflections. Okay, so these are the two identical beams. Okay, and this is the roller, and this is the load acting over here on this beam. Let this is beam number 1 and this is beam number 2. Okay, so based on this configuration, we have to predict the deflection and slopes at the free ends will be equal in both the beams or unequal. Okay, both the deflections and the slopes. Okay, so first let us see what will be the deflection. Let y1 be the deflection in beam number 1 and that in beam number 2 be y2 and theta 2. Okay, so first deflection. See, at the initial condition both the beams are in contact with the roller, and after applying the load also these two beams are to be in contact with the roller, and it is told that the roller is a rigid roller, that is the roller is not going to crash. Okay, so the amount of deflection will occur in the top beam. The same amount of deflection has to be occurred in the bottom side beam, right, to keep in touch, and it will be in touch, right, from this configuration. So it's evident that the deflections will be same, that is y1 is equal to y2. Now the slope, let this is the beam number 1. Okay, so clearly this P will be divided into two parts. Let P1 is transferred in the beam number 1 and P2 be carried by the beam number 2. P1 plus P2 is equal to P. Okay, so for the beam number 1, clearly it's a cantilever beam carrying a concentrated load at the free end, right? It's like this, P1. So for this type of loading, we know that the beam will deflect like this, right? And if we draw a tangent over here, so this will be theta 1, right, the slope of the first beam. And for the beam number 2, the clearly the applied load is working here, and here at the roller contact there will develop a reaction force equal to P1, right? So if P1 load is transferred to the beam number 1, then beam number 1 will provide a equal and opposite reaction P1. See, based on the extent of load, it may deflect in different shape. Let us see. For lesser value of P, it will deflect like this. Since the external load is acting over here, so the curvature will be less than this curvature. I mean, here the radius will be less, here the radius will be high. This aperture will be less here, okay, in comparison to this. So here, if we draw tangent over here, this will be theta 2. And if the P is higher, I mean for some value of P, this deviation may be like this, that this is a straight line, almost like straight line. Okay, so in that case theta will be this one, theta 2. And for again higher value of load, the deflection may be like this, even this concave, due to this load, external load P, and here P1. So in that case, if we draw tangent over here, then it will cut this initial position at this extended line. In that case, this will be theta 2. So based on the extent of applied load P, it may deflect in different way. Okay, so clearly theta 1 is different from that of theta 2. So slopes will be different. So option number A is the correct answer. Equal deflections but not equal slopes.